So, now using differentiation, we have seen that how we can solve the problem related to optimization. So, in order to find the maxima and the minima, we if our function is a differentiable function, we look at the where f prime is equal to 0. Now, if f prime is equal to 0, then what we are essentially geometrically there is a tangent parallel to the x axis, which means either there will be in a neighborhood in which it is going to have the maximum or a minimum. Then we need to check that. So, if f is differentiable in that. So, now for example, let us consider f of x, this is equal to 2 x cube minus of 3 x square minus of 12 x plus 1 on minus 2 to 3. So, we are interested in find the absolute maximum and minimum, absolute maximum and absolute minimum. So, for this we find out the derivative. So, the possibility point where the absolute maximum and absolute minimum can happen, this is 6 x square minus of 6 x minus 12, which is equal to 6 into x square minus of x minus of 2, which is equal to x square, which is equal to 6 times x minus of 1 into x plus x plus 1 into x minus of 2. Okay. So, therefore, f prime of x, this is equal to 0 if x equal to negative 1 or 2. So, which means we need to find the, in order to check for the absolute maximum and minimum, there are possibility that either of these 2 point or at the end point minus 2 and 3. So, if we calculate f of minus of 2, then this is going to be minus of 3, and f of minus of 1, then this is going to be equal to 8, and then f of 2, then this is going to be equal to negative 19, and then f of 3, this is going to be negative 8. So, absolute maximum is attained at f equal to minus of 1, absolute maximum at x equal to negative 1, and absolute minimum is equal to minus 19. In this example, it is happening at the critical point, but in many of the example it may happen at the end point. So, whenever there is a question about absolute maximum or absolute minimum, make sure that you are going to calculate the value of the function at the critical point as well as at the end points. So, and also there are very powerful and important result is Rolle's theorem and the mean value theorem. So, remember that the condition for the Rolle's theorem and the mean value theorem is f continuous on a b and f differentiable on a b. Now, for the Rolle's theorem, if f of a equal to f of b is equal to 0, then if there is a point between open interval a b where f prime of at that point is going to be equal to 0. So, now that many a times we can apply Rolle's theorem to figure out about how many roots of an equation can have. So, for example, if I look at x cube plus 7 x square minus 2 x plus 1 So, obviously, what we can say that this is a polynomial of degree 3, therefore, it is certainly going to have a real root, because when x goes to infinity, this goes to infinity, when x goes to negative infinity, this goes to negative infinity, and this is a continuous function. So, it has to be 0. Now, one thing is that if it is a odd polynomial, then we can say that very easily that it can have at most maximum number of roots it can have is 3. So, has at most 3 roots. So, now suppose it has 4 roots. That means this. Now, these are the 4 points in which there is. So, definitely this is a differentiable function. So, by Rolle's theorem there will be a root of f prime is going to be 0 somewhere here, f prime is going to be 0 somewhere here, and f prime is going to be 0 somewhere here. So, therefore, f prime is going to vanish at least 3 points by Rolle's theorem if f has 4 roots. Now, let us calculate f prime. What is our f prime? F prime of x is equal to 3 x square plus 14 of x minus of 2, and this is a quadratic equation. How many roots it can at most have? 2 roots, but if f has 4 roots, then definitely f prime is must have 3 roots, but f prime is a quadratic equation, therefore, it can have at most 2 roots. So, this is a contradiction, this is wrong. So, any cubic polynomial of degree 3 can have at most 3 roots. It is not necessarily one can say that all the roots will lie on the real line. What we can say is that there is at least one real root and at most 3 roots. Okay. So, this is a simple application of Rolle's theorem. Similarly, in mean value theorem, mean value condition is f is continuous on closed interval a b and differentiable on open interval a b. So, now by using mean value theorem, we can prove various inequalities. For example, this inequality, look at this, 1 plus x is less than 1 plus x by 2 for all x greater than 0. So, how does one prove that? Let me define f of x equal to square root of 1 plus x, and g of x, this is equal to 1 plus x by 2. Therefore, f of x minus of f of 0 divided by g of x minus of g of 0 by mean value theorem, it is f prime of c by g prime of c. Now, this one is square root of 1 plus x minus of 1, and this is I can do this, I do not, f of x minus of 1 by g of x minus of 1. This is equal to some f prime of c, this is 1 by 2 square root of 1 plus c, and then this is divided by g prime of x is going to be g prime of c, this is going to be 1/2. So, this is 1 by 2 square root of 1 plus c into 2, this is equal to 1 by square root of 1 plus c. Now, this is definitely less than, where c is between 0 above. So, 0 to infinity. So, this is less than 1. Therefore, f of x minus of 1 is less than g of x minus of 1. This will imply that f of x is less or equal to g of x. So, by applying mean value theorem, we can find out various inequalities. Another very important feature of this application of the derivative is also finding the limit by so called L'Hopital rule. L'Hopital rule, as we have seen with the certain conditions on differentiability condition on f and g, if limit f of a 0 by 0 form, infinity by infinity form, 1 to the power infinity form, 0 to the power infinity form, all these can be calculated, but remember all the time you check the condition of the L'Hopital rule. So, we will do a concrete example. So, if we want to find limit x goes to 1, 2 minus of x to the power tan pi x by 2. So, here this is actually this is 1 to the power infinity. So, what we do is that this you define and then ln y is equal to tan ln 2 minus f is 0. So, now you can define 1 by tan . So, this now becomes 0 by 0 form. So, you apply your L'Hopital and then you can find out the limit. Okay. And of course, there will be various applications of derivative what we have discussed in the class. So, the previous lecture. So, now we come to the integration, we will do some problem involving the integration. So, how do you define? We define the Riemann sum of an integral of a function, then we take the limit, and what we get is that if that limit exists, then we say call that to be a Riemann integration of the function. So, for example, if you look at this limit of n goes to infinity, summation over I from 1 to n, and 4 minus 3 x I square x I star square plus 6 x I star to the power 5 x I plus 1 minus of x or x I, here I am taking from 1 to, so x I minus x I minus of 1. This we have also denoted it by delta of x, and where x I star we have the freedom to choose anything with any number between x I minus 1 to x I. Now, this limit what we have denoted is going to be this, if I am looking at on 0 to 2 in this interval, then this is 0 to 2 4 minus of 3 x square plus 6 x to the power 5 dx, which we can compute. And also if a function is Riemann integrable, we have seen that in order to take the partition, if you take the equal partition, then also this is going to give us the Riemann integration. For example, if we are asked to find limit n goes to infinity, summation over k from 1 to n, k to the power 4 by n to the power 5. Now, this I can write this, that limit n goes to infinity 1 by n, I pull it out, this is k by n to the power 4. So, basically now if I divide the 0 1 into n equal parts, then this is 1 by n, this is 2 by n, like this I go on to 1. So, here k by n is the value of the function. If I consider the function f of x equal to x to the power 4. So, I am taking all the values at the right end point of the partition. So, this is an integrable function, continuous function. So, what we get that this is x to the power 4 dx. So, that is very cute. Okay. So, then of course, one of the very important feature of this is integration is that the fundamental theorem of calculus, which actually relates the integration to the differentiation. So, now when you have, let us say, f of x is equal to 2 to x t to the power 4 cos t dt, then f prime of x, this is equal to uh, x to the power 4 cos x. Now, instead of this, if I had been given to calculate, given that f of x is equal to, and I am asked to calculate f prime of x, then what I am going to, now this is a composition. So, what we have to be careful, this is basically x square to the power 4 cos x square, and then the derivative of this x square. So, that is going to be 2 x. So, this is going to be 2 x to the power 9 cos x square. You see, so be very careful about whether it is x or some function of x. If it is a function of x, then you need to be careful about it. And then we learn a very powerful tool of the substitution. So, with the substitution we can actually compute many integral. So, for example, this is 1 to e ln x by x dx. So, if I take y to be ln of x, then dy, this is equal to 1 by x dx. So, now if x is equal to 1, then y is equal to 0. If x is equal to e, then y is equal to 1. So, this integral becomes 0 to 1 ln y is y, and 1 by x dx is dy. So, this is as simple as that. So, that is very easy to compute. Then through the integration, the way we have defined, we have calculated, actually the integration is essentially nothing but the area under the curve. So, we can use this integration to find the area of certain region. So, area of the region enclosed by y equal to sin x, y equal to cos 2 x, and x equal to 0 and x equal to pi by 2. So, as you can see that y equal to x equal to 0 is this, x equal to pi by 2 is this, and so sin x is, this is 1, and then the cos 2 x, is, this is pi by 2. So, which means pi by 4, this is going to be. So, this is, so now we need to calculate the area of this region. So, now we need to figure out where these two curves meet, that means sin x is equal to cos 2 x. This is equal to 1 minus 2 sin square x. If you calculate, then this is, we are going to get that this will imply that x equal to pi over 6. So, now in this is pi over 6. Now, we need to find the area is 0 to pi over 6, and here cos 2 x dominates sin 2 x. So, this is cos 2 x minus of sin x dx. Now, in this pi by 6 to pi by 2, sin x is dominating cos 2 x. So, this is sin x minus of cos 2 x. You need to be very, very careful about the region in which function dominates what. Then this becomes an easy integral to calculate, which you can calculate it very easily. Okay. Integration, we can find the volume of certain solids. Uh, Basically, now suppose for example, consider the curve y equal to x to the power 4. So, this is going to look like this. Now, I try to rotate it along the y axis. So, now if you rotate along the y axis, so this is going to be this. I am going to get a figure like this. So, all where this is circle. Now, I want to find the volume where this is equal to y equal to 4 by rotating this. So, now I slice it. So, what I am going to get is a kind of an approximate cylinder here, and this is going to be delta y. So, area of the cross section I need to find is equal to pi, and you remember that this radius of this circle is going to be x square. So, this now what is your x square? X square is square root of y. So, now the volume of the cylinder is approximate cylinder, volume of approximating cylinder is the area into delta of y, because that is the width. So, pi square root of y into delta of y. So, therefore, the total volume is, I am interested from here 0 to y equal to 4, and then pi times square root of y dy. So, this you can compute it. This is pi into 2 by 3 y to the power 3 by 2 0 to 4, which is equal to whatever the value it is going to come. Okay, that is easy to calculate. Also, through this integration process of integration, we can compute the arc length of the curve. If our curve is nothing but a continuous function from what we can say parametric curves are from some interval to R2, which is a continuous function. And then if each coordinate r of t is equal to x of t and y of t, then if both this x as a function of t is differentiable, y as a function of t is differentiable, then we know how to calculate the arc length of the curve. So, what I need to find the dy by dx, so which means I would find dy by dt and then dx by dt, and we can find the dy by dt. Okay. So, there also Riemann integration talks about the bounded interval and the bounded function. So, we can now ask ourselves about that whether we can integrate some unbounded function or we can integrate in some unbounded domain. So, can we extend the concept of the Riemann integration to this unbounded function and unbounded domain, and that is where we discussed about improper integral. So, one of a very powerful tool of the improper integral, whether the improper integral converges or not, is by comparison. So, let us do one exercise. So, given let us see that whether this 1 plus e to the power minus of x by x dx. So, as you can see here, we are talking about the integration in an unbounded domain, and so the function is nicely behaved. So, then what you see is that this 1 plus e to the power minus of x by x, this is definitely greater than 1 by x, and integral over 1 by x dx 1 to infinity diverges. Therefore, this integral diverges. because this is this integrand is greater than 1 over x and that diverges. Similarly, if we want to find dx by square root of x into 1 plus x. Now, this is unbounded domain and the function is also unbounded. When it goes to 0, then this is blowing up. So, now for this what we do is that we define 0 to 1 dx by square root of x into 1 plus x plus 1 to infinity dx by square root of x into 1 plus x. Now, here what I have done, here I have taken broken into two parts. One is the bounded domain unbounded function and the second part is the unbounded domain, but bounded function. So, this is let us say for 1 and 2, and for 1 I can see that 1 plus f x is greater or equal to 1. Therefore, 1 square root into 1 plus of x, this is less or equal to 1 by square root of x, and this we know that is integrable. Therefore, this is integrable. Now, for the second, what we can 1 plus x, we can take it to be greater or equal to x. Therefore, 1 by square root of x 1 plus of x is less or equal to 1 by x to the power 3 by 2. Therefore, from 1 to infinity 1 by x to the power 3 by 2, this converges. Therefore, this total integral this converges. So, now briefly just one lecture back we have done the infinite series. So, I am not going to do much of the exercise on the infinite series. So, remember that there are few important things. So, this is the comparison is very powerful in the infinite series, but we need to have the same sign. If you have a positive term, first you need to see that whether a n converges to 0 or not. Then you try to compare if you have a positive term, and then you have got the root test and the ratio test. There you can conclude about the convergence of the series, and many a times it is very useful that if you have a telescopic sum, then you can determine the convergence of the series very quickly. For example, you see summation over, suppose I have given 1 by n cos 1 by n minus 1 by n plus 1 cos 1 by n plus 1. So, n equal to 1 to n. So, now this is going to be, there will be cancellation is going to happen. So, you are going to get that cos 1 minus 1 by n plus 1 cos 1 by n plus 1, and this is cos is dominated by 1. So, this goes to 0. So, whenever you have an telescopic sum, then the partial sum converges, that sometimes become very very useful, and also then the comparison test, root test, and then ratio test. These are ratio. So, these are very powerful methods to determine. Suppose for example, if you look at n 2 by 3 to the power n equal to 1 to infinity to determine the series. So, this is your ans are positive. So, you can apply root test. So, an to the power 1 over n, this is n to the power 1 over n and then 2 by 3. N to the power 1 over n is what? That goes to 1. So, this goes to 2 by 3, which is less than 1. Similarly, with the ratio test you can find out various. So, I hope this exercise in the last lecture, from some selected exercise and from various topics is going to help you for your preparation for the exam. Thank you.